All right, we're still looking at lesson 8.2. We're on task 3. So to graph transformations of the absolute value function, you can stretch or compress the graph of the parent absolute value function f of x equals the absolute value of x by changing the value of a in g of x equals a times the absolute value of x, or by changing the value of b in h of x equals the absolute value of bx, where a and b are non-zero real numbers. Alright, so it says compare a stretched and compressed graph of the parent absolute value function with the graph of the parent absolute value function. Alright, so if you look at g of x equals 3 times the absolute value of x, if you plug in these values, these are your output, these are your y values. If you do h of x equals the absolute value of 3x, again, we're going to put in the same x values, and we got the same y values out. So in this graph, g and h are the same red line because the points are the same in the table. All right, so in the blue line is still the absolute value parent function. All right, so it says to what point on the graph of g is the point 1, 1 on the graph of f mapped? All right, so what point does this go to? It goes to 1, 3. All right, how does the value of a affect the slope? All right, so it's no longer a slope of 1. Before it was like rise 1, run 1. Now it's rise 3, run 1. All right, so on the left side, this is the two slopes. You can see that on the left side, it goes down 3 over 1. So this side has a slope of -3, and this side has a slope of 3. So don't let that confuse you. The slopes of the pieces change from -1 to -3, and from 1 to +3. Okay. All right, to what point on the graph of h is the point 3, 3 on the graph of f mapped? Okay, so it would be the same thing because g and h are the same. So it's going to be 1, 3. And how does it affect the slope? The exact same way, because again, f and g are the same. So -1 goes to -3, +1 slope goes to +3. What are the domain and range of g and h? Select all that apply. The domain of g and h are all real numbers. That's true because your domain goes left and right with arrows, so that means it's all real numbers. Non-negative, so we don't have non-negative or positive. We do, but we also include the negatives, which means we have to choose the first one. All right, so then we talk about the range. The range of g and x have all real numbers. That's not true. The range of g are all non-negative real numbers. And the range of g is all positive numbers. Okay, so when we look at the graph, we're going to choose non-negative because non-negative includes 0. So it comes down to 0. Both the parent function and the translation comes down to 0, 0. 0 is included. So 0 is a non-negative number, but it's not positive. So this one, you just got to be careful to choose the best answer. So the range is not all real numbers. It is non-negative real numbers. See, positive numbers leaves out 0. So we do need to choose the non-negative. All right, can changing the value of a or b in the function y equals a times the absolute value of bx ever affect the domain and range? Select the correct words to complete this statement. All right, only a blank value of a can change the range. All right, only a negative value of a. Remember, if it's negative, it flips it upside down, so it would go down instead of up. So the range to a non-positive. So that also would be to include 0 as well. So we don't want to choose negative because remember, negative plus 0, we have to choose the non-positive. So the only time that's going to change, or the range will change, is if you have a negative value of a, which would be a reflection across the x, and flip it upside down. All right, that's all for task 3. If you have any questions, let me know. Lesson 8.2, task 4. Construct functions for transformations of the absolute value function. You can use what you know about transformations to write an absolute value function given its graph. The graphic organizer summarizes how each parameter in an equation for an absolute value function affects its graph. All right, so we looked at some transformations before, and this should look very similar. So transformations of absolute value functions. G of x equals a times the absolute value of x minus h plus k, where a, h, and k are real numbers. A is not equal to 0. All right, so remember h and k will be your vertex. H is going to move you left or right, depending on the sign. So if h is greater than 0, or h is positive, you're going to move to the right. If h is negative, you're moving to the left. K moves you vertically, up or down. So K is going to move you up if it's positive, down if it's negative. Stretches, compressions, and reflections. All right, so if A is greater than 1, it's a stretch. If it's less than 1, it's a compression. If it's between -1 and 0, it's a compression and a reflection across the x-axis. So -1 to 0, these are negative numbers, and that's why it also includes a reflection. A equals -1 reflects across the x-axis, and A less than -1 is a vertical stretch and a reflection across the x-axis. All right, construct the function of the form g of x equals a times absolute value of x minus h plus k for the given graph. All right, so we're trying to write a function, so we're trying to figure out what is a, h, and k. All right, so we can see that the vertex has moved left, but it has not moved up or down at all. So A part says complete the following sentence. The coordinates of the vertex of g of x equals a times the absolute value of x minus h plus k are. So what are the vertex coordinates? So they're calling it x and y, but that's really just your h and k as well. So your vertex is going to be shifted over, left 1, and up 0. All right, it says the graph is translated to the left 1, so h is -1. The graph is not translated vertically, so k is 0. The graph is stretched vertically by a factor of 2, so a is either -2 or +2. So you can look here and see that rise 2, run 1, so the slope is 2, and over here it's -2. All right, you can use the reference points on the transformed graph to calculate the slope. That's what I just did. So the slope of the ray on the left is negative, and the slope on the right is positive. Since the graph is not reflected across the x, a is not negative, so that means a is positive too. So the V-shaped graph is pointed up, means it's positive a. If it was upside down V, it would be a negative a. All right, so it says the function is g of x equals 2 times the absolute value of x. All right, so there's a mistake here. So this says x minus 1. So our x is -1 because it moves to the left, but in our function it's x minus h. So this actually should be a +1 here. So just change that to a +1. And you can double check that by looking at the graph. So if you want to graph this function, go to y equals. All right, y equals, and 2 times the absolute value. If you hit math and you arrow over to where it says number, the first one is absolute value, so hit enter, and then x plus 1. And again, remember the x plus 1 comes from the minus 1. And then plus 0, it's not shifted up or down at all. And then you can hit graph. So you can see that that is the graph of the function that we had above. So just make sure you see that they did have that incorrect here. All right, if you want to check the other function, the one that they have, you can graph it as well. You can see that it is 2. Go to Math, Absolute Value, and hit x minus 1. And if you remember, it's going to translate you the other direction. So it's going to translate you to the right. So that is not the graph that we need. The one that we need has a plus sign. If you go all the way back to the top, you can see this translated to the left, not to the right. Okay, so that is all for task 4. If you have any questions, please let me know.